is going to be good for us today. Here we go. Okay. It says, use your Chromebook to solve with Desmos. All right. So we've got a cubic function. Let me go to my apps. If you haven't already, go to your apps. Go to Desmos Graphing Calculator. Click the fourth one down, and it's green. And we're going to go ahead and type in our equation and look for our solutions. Where do the solutions live on the graph? Where? X-axis. So that's what I'm looking for in particular, are solutions that live on the x-axis. Okay. X. I know you can't see right now. I will move my Chromebook in a second. Remember to hit Shift 6 to get your exponent. Arrow to the right to get it to pop back down. Okay. So you practice typing it in too. Here's my equation typed in, and then here's what the corresponding graph looks like. Again, make sure you are practicing typing it in now. It's just the front. Make sure you're practicing typing it in now, because again, you don't want the first time you practice typing it in to be the day of the quiz. Right? Like, that's why we practice stuff, so on quiz day we're good to go and we feel confident. So make sure you're typing it in right now. Make sure your graph matches mine. And we are looking for solutions. And somebody told me a minute ago that my solutions are my x-intercepts, and I 100% agree. So basically what I'm looking for is where my graph touches the x-axis. So I'm going to hover, and ooh, there's a solution, and it's a good one. -1, 0. Remember, if they aren't good ones, we're going to have to approximate our decimals. Here's another one. Okay, so that's one I would say isn't quite a good one. So we need to practice cutting off and rounding. So we call that truncate and round. So remember, we like 2 spots after the decimal. So I'm going to cut right here. Would I leave it as an 8, or would I round it up to a 9? Leave it as an 8, because the number that comes after it is a 1. So I'm going to do 1.38, 0. And then the last one looks like it's not super nice either. 3.62, good, 0. So again, we're truncating, which means cutting it off, and we're rounding. I'll show you my answers in just a second that I wrote down. We're going to use Desmos one more time, so we're going to leave the Chromebooks out and open, because we do need them for the next one as well. All right, so here's what I wrote on mine. I wrote them as ordered pairs. You could also write x equals -1, 1.38, 3.62. So this is acceptable for an answer. So is this. You don't need both, one or the other. Okay? We don't need both. Good? We're very quiet. Good? Yeah? Okay. At least need head nods or something. I get that it's a Monday. All right, we have got a rectangular prism, which is basically like an Amazon box on your porch. Okay, so we have this thing sitting here, and we want to write an equation to represent it. And in particular, we're working with the volume. So it doesn't say it, and it also doesn't say it on the quiz. It's kind of in a, they try to get you to assume it's volume. I don't know why you would just assume that. Because you could also find surface area or other stuff, right? If you really wanted to. So truly what we're finding here is volume. How would I find the volume of this Amazon box? Length times width times height. So I'm going to I'll take this first. And then I'll pick this. And then I'll pick this. Now, with this problem, remember that you have something called the commutative property and the associative property, and this is all upheld by multiplication of just polynomials. And so if you had the x first, and then you had the x minus 2, and then you had the x plus 4, that'd be okay, right? Because we can multiply in either order and still get the same answer. 2 times 3 is 6. 3 times 2 is also 6. You can leave it like this. I'm fine with that. Or you can FOIL it out. It's up to you. So FOILing it out would mean that you would distribute the x and the 4, and then you would multiply through finally by the x. But you can leave it like this. So this is my equation. This is my length times my width times my height. Now we want to use Desmos to solve for an answer for part A. Ooh, I need to give you one more piece of information though, and that is the volume. Hold on, I have it written down somewhere. Give me 30 seconds. Okay, the volume is 819, so I will give you that information as well. So it says use Desmos to solve the situation in part A, and the volume is equal to 819, and it said cubic inches. So it will give you this information in blue. That's my bad for not having it on there. Okay, so we're going to use Desmos to solve. Do you remember how we did this before? We're going to graph two things. So we want to graph two different equations. So we'll call them y1 and y2. Does anybody remember what one of the equations was that I should graph? 8. Yeah, just 819. So just that. What's the other equation I should graph? Yeah, this one, right? So my x times x plus 4 times x minus 2. So I'm going to graph both of these. Again, I can't stress enough, that is going to be given to you. I know that I didn't have it written in, but that will be given to you. So I'm going to graph both of these, and kind of like we did back in chapter 2, we're looking for the intersection for where our solution is. So I'm going to come back to my Chromebook. So this is another Desmos problem. And you can type it in with parentheses. So x, parenthesis, x plus 4, close it, parenthesis, x minus 2, close it. And then we want to come down here, and we want to figure out when, I think we had to put y equals, didn't we? Yeah, put y equals 819. I feel like when I just typed 819, it did not like that. I'm remembering back to when we did that earlier. Okay, so those are my two equations. Now, if I move over to my graph, I can see up to 6. That's not really going to help me, is it? I need to go way further up to 819. So I'm going to zoom on out, and I'm also going to drop and drag and move my graph up until I get to the spot I want to get to. Do you see how right here I can see the intersection? I've got my blue line at 819, and I've got my cubic function here. So what does my x value have to be? In order for my volume to be 819, what does my x value have to be? 9. So when it asks you to solve, it wants to know what the x value must be. So the x value must be 9 inches. If it asks you to go back and find the length, the width, and the height separately, I can plug it in, right? So my length would be 9. My width would be 9 plus 4, which is 13. And my height would be 9 minus 2, which is 7. So if they just ask for the x value on the quiz, then you would just write what the x value is. If they ask you to go back and find the dimensions, then you would write this. So both these pieces of information are pertinent. Do we have questions about that for number 2? We've seen a couple of these, and I know I don't always have story problems on quizzes and tests, but if we've done a couple of them in class, there's probably going to be one on the quiz, yes? Okay. All right, let's take a look at the factoring next. Questions before I put my Chromebook away on 1 or 2? Okay. Let's look at the factoring ones. Start with 3A. You have 4 terms. If I have 4 terms, what do I know I need to do? Grouping. So 4 terms tells me to group. Okay, so 4 terms means group it up. All right, when I look at how to group, do you agree that the first 2 terms have a bunch of x's? And the second 2 things are both divisible by 3. So I'm going to group the first 2 and last 2. We talked about the fact that you don't always group the first 2 and last 2, but about 95% of the time that's how the problems end up in our textbook that we're using. All right, if I ignore the second part for a minute, what can I take out of the first 2 terms? X squared. If I take out an x squared, I'm left with 2x minus what? 1. Yep. Okay. Let me move over to the other side now. Move my post-it note here. All right, so we've got a positive. What can I take out from these 2 terms? 3. If I take out a 3, in parentheses, 3 times what is going to get me back to 6x? 2x. And 3 times what is going to get me back to -3? -1. All right, so we were hoping that the thing in our parentheses would be the same. Was it? Yeah. So here's thing 1, here's thing 2. We're going to make 2 sets of parentheses. 1 is for what they have in common. What do thing 1 and thing 2 have in common? Yeah, 2x minus 1. And then what are my leftovers? Plus 3. Okay. Now, normally when we have something squared, we have to think, ooh, can I factor it further? But do you see how this isn't a difference of squares? That's what you're going to want to be on the lookout for, is a difference of squares. That's not what this is. This is a perfect square. This isn't, and this isn't a difference. So this is my final answer right here. So we don't have any further that we can go in terms of factoring. So when it says just factor, it's a lot more simple than when it says factor and solve. Solve adds that whole extra dimension that we have to find all the missing parts. All right. Same for this one. Just factor makes our life much easier, especially for the cubic ones, right? Because we wouldn't have to do quadratic formula. All right, so this is a difference of cubes. 2 parentheses, 1 small, 1 big. It's a difference of cubes, so my signs are minus, plus, plus. So that's a memorization thing, right? To remember what the signs are and also remember how to fit things inside. We're going to take the cubed root of the first term. What's the cubed root of x cubed? I agree with 4 for the 64, but what about the x cubed? Just x, right? So if we take the cubed root of x cubed, it's x. If we take the cubed root of 64, it's 4. All right, we're going to take our first term and square it. What do I get if I square it? X squared. We're going to take our last term and square it. What do I get? 16. And then I'm going to multiply them together. 4 times x is 4x. And we also talked about the fact that no matter how much we want this to be nice and factorable, because it's a trinomial, it's never going to be. So these are going to be one step and done as well. These won't be problems that you have to go further. You do. Yep. It's the only time I'll ever tell you to ignore the signs. So when you multiply these together, yep, you ignore the sign. Okay, let's do the last one that's just factoring. And I'm running out of space, so I'm going to grab a separate sheet of paper. If you wrote as big as I did, maybe you need an extra one too. So part C says 64x squared plus 48x plus 9. So remember that when we get a coefficient, these have been our perfect trinomial ones, or our perfect square trinomial ones. Okay, So when we have perfect square trinomials, we're going to get the same set of parentheses twice. And it's very similar to the difference of squares. So we take the square root of the first term. What's the square root of 64x squared? 8x. So that goes here and here. What's the square root of 9? 3. So that goes here and here. Do you see how everything's positive? Do I have any need for any negatives anywhere? No. So I'm going to put pluses here and here. So take a look. This will multiply back to 64x squared. 3 times 3 will multiply back to 9. Do you see how this is going to give me 24x? Is 24 plus 24 take me back to 48? Yep. So it worked out perfectly. Now remember, we're going to go one step further and tidy it up and say it's just that set of parentheses squared. And again, we're just factoring, we're not solving here. So we can just factor and walk away. The next two are the ones that are trickier. Those are ones where we have to factor and then we also have to solve on top of it. How are we doing so far? Okay? Give me a fist of 5. I don't feel like I'm getting much info back from you. Fist bad. 5 good. Others somewhere in between. Okay. Thank you. Thank you. Okay. Alright. Thank you. Alright, let's keep going. The next two are the factor and solve. I'm going to keep going on the separate sheet of paper because I have run out of room. And I write a lot and I write large so you guys can see it. So the directions are factor and solve. I'm going to just write the problems. Part A was x cubed minus x squared minus 20x equals 0. Part B is x cubed plus 125 equals 0. Okay, those are my two. Here we go. Let's start with part A. Always when you're factoring, we look if there's something in common. Is there anything in common that I can take out of everything? Yeah, let's take out an x from everything. That's going to make my life a little bit easier. So if I take out an x, think backwards. X times what is x cubed? X squared. X times what is x squared? Just an x. And it was negative because of the minus out front. And then what do I need here? X times what will get me to negative 20x? Negative 20. Okay. On the factor and solve, unlike the just plain old factor, if it's something that's squared, I've definitely got to keep going, whether it factors nicely or not. So let's first see if it factors nicely. If it doesn't, we're going to have to use the quadratic formula. X times x is x squared. This is a trinomial. Remember, with trinomials, we play the game of what multiplies to negative 20, but adds or subtracts to negative 1. So let's think about what multiplies to 20. What are our options? 1 times 20, what else? 5 and 4, what else? 2 and 10. Of that list, what values could add or subtract to a negative 1? 5 and 4. So I'm going to use 5 and 4. Again, it doesn't matter what order. The 4 could have gone first and the 5 second. Which one gets the plus and which one gets the minus? Yeah. Negative 5, positive 4. Take a look as to why. X times x is x squared. Negative 5x plus 4x gives me negative 1. Negative 5 times 4, that's how I get to negative 20. So let's solve this. So I have 3 things being multiplied together that equal 0. The zero product property says one of those things must have been 0. What would make this 0 if x were? What would make this 0 if x were? Positive 5. What would make this 0 if x were? Negative 4. And I'm done. So some of them will be just that easy where you can factor and you can solve and all the answers come out nice and everything's kind of happy and rainbows. Part B is not happiness and rainbows, unfortunately. We're going to have to do a little bit more. Okay, we need to factor. It's a sum of squares. 2 sets of parentheses, 1 small, one bigger. It's a sum of squares, so I need minus, plus, plus. Nope, sorry, plus, minus, plus. What are you doing, Miss Vessel? There's always one minus in all of these. If you put in more than one minus, we're doing something wrong. This one is plus, minus, plus. Sorry about that. And now I have white all over me. Okay. If I cube root the x cubed, what do I get? 3. If I cube root the 125, what do I get? 5. So I've got an x plus 5 in the first parenthesis when I cube root both the parts. I'm going to take this and square it. If I square x, I get x squared. If I square the 5, I get? If I multiply them together, 5x. Okay. I have two things being multiplied together that equal 0. What would make this thing 0 if x were -5? Do these gems ever factor further? No. So that means that we need to use quadratic formula. So we're going to use quadratic formula. This won't be given to you on the quiz, so you need to walk in having this stuck in your head. Opposite of b, plus minus, square root, b squared, minus 4ac, all over 2a. Now, we can ignore this. We already solved it. We already took care of it. We can even cover it up. Like that's done. So we're going to look just at this part. What's my a value? What's my b value? And my c value is 25. So I'm just using those values, and I'm going to plug them right on in. The opposite of -5, or -5, is really what? 5. Plus minus the square root of b squared. Remember, when you plug it in, it has to be plugged in a parenthesis house. Minus 4 times a times c all over 2 times a. So I just plugged everything in. So here is the opposite of b. Here's b squared minus 4 times a times c all over 2 times a. Good? Okay. So let's continue. 5 plus minus. I need my square root, and it's being divided by 2 times 1, which is just 2. Let's figure out what lives under that square root. So I'm going to type it in. Parenthesis, -5, close it, square it, minus 4 times 1 times 25. I get -75. Okay. I can't take the square root of -75, but I can break it apart. -1 is something I need to break apart. Which one of my perfect squares divides into it? 25. And then I know 25 times 3 is needed to get back the 75. So I get 5 plus minus. What do we know the square root of -1 is? I. What's the square root of 25? And then we can't take the square root of 3 and have it be nice, so it's just going to live on underneath. Sometimes there's even one more step, believe it or not, because sometimes we can divide by 2 or whatever's in the denominator. Are these things divisible by 2 though? No. So this is my final answer as it stands. I'm going to box that in. It is a lot. So this is the stuff that's on the quiz tomorrow. I'm not hiding anything from you. This is what it's going to look like. So you need to be able to do all of those different things. The video will be posted.